Still seeing it. So I'm going to leave some space here for us. 1 over square root of x plus 3 minus a half. That's the top over the bottom. I left some space in here for me to put my what I need for the common denominator. So I'm going to need over here a 2 over 2 so that they both have a 2 in the denominator. And then this one is going to need a root x plus 3 over a root x plus 3. And that way they both have the same denominators. And then limit x approaches 1. All right, when I do these two together, right, I get 2 on top. On the bottom, I get 2 root x plus 3. And then minus, when I do these two together, multiplying straight across, I get root x plus 3 on top. On the bottom, I get 2 root x plus 3. But don't forget, all of this is still over x minus 1. Now, I could have put them together like on the, I didn't have to write that line, but I want to make sure everyone sees I've got common denominator now. Do not do this. Don't cancel these 2's and then cancel the roots, because then you go right back to where you started, right? Like the whole reason we did this is so we could put these together. So my next line is going to be the 2 tops together. So 2 take away root x plus 3. And then the denominator is the common denominator. Both of these together, not together, but rewriting the common denominator. And then all of that, don't forget, is over x minus 1. So you got a lot to keep track of, right? Now, if you try and take the limit right now, you're still going to get 0 over 0. You're not going to be done until this x minus 1 goes away. When that x minus 1 goes away, then you will know you're finished. So now the conjugate. Now I'm going to bring the conjugate in. So the way I'm going to choose to do the conjugate is like this. I'm going to do 2 minus root x plus 3 over 2 root x plus 3. All of that over x minus 1. Now here comes my conjugate. I'm going to do it like this. Because the numerator is already a fraction, I'm going to do it right here. I'm going to do 2 plus root x plus 3 over 2 plus root x plus 3. Just like that. Well, that's why I said, because we have a complex fraction, you can either put it like this, because that's a 1, right? And this is going to go on the top, and this one's going to go on the bottom. Or you could have done that up top, and then bring this one down here. You could do either way. I just chose to put it together because this is a fraction right there. Both ways would work. All right, where are we at? Umberto. No, wait, hold on, I called on you last time. Philip? There's no Philip? No Philip? Uh-oh, I'm having trouble with this one. Is it Joaquin?
Joaquin.
What, is it Joaquin? I'm trying too hard. Say it again? Yes. So Joaquin? Okay, I tried too hard. All right. Okay, Joaquin, I like that name. It's unique. Are you following? Because I know you emailed me, right? You weren't here last week. Okay, are you okay today? You following along?
Yeah.
Okay, I'm going to give you another day. I won't call on you right now. But you're here, right? So good. Let's see. Who have I not called on? I feel like I haven't called on. I mean, in both the last 2 days. I've never called on you? First day? Okay. All right, let's just keep going through people then here. Umberto. Umberto, are you following?
Yes.
Okay, so help me out. Help me with this right here. What do you got?
Well, the roots would cancel out, right?
Okay.
It would be 4
So 4, so 2 times 2, that's your 4. You're not worried about the middle ones, right?
Sorry?
Like the middle terms will just kill each other off, right? So now you just go to the 2 roots together, right? So this, be careful. This is the part that messes people up. The roots are going to go away, right? Which leaves you with what? X plus 3. But is it going to be plus or minus that? Because this is a negative root, right? This is a positive root. So it should be what? Minus, right? Minus x plus 3. Is that correct? No. Because it has to be minus whatever the roots turned out to be when you multiply them together. So you have to have that minus sign in front. If you don't put that minus sign, then this negative doesn't distribute, and then things don't work, all right? So you know that a negative times a positive is negative, and then the root times the root gives you the x plus 3. That negative will still have to pass through. Good? Okay, now that's on top of, let's stick with you here, Umberto. Should I multiply these together? What do you think? Do you want to?
Yeah.
I mean, you could, right? Wouldn't it? But this would be kind of nasty, right, to multiply this all together? Our ultimate goal is to make this x plus 1 cancel, right? So anything that I don't have to do, I'm not going to do. So I'm going to choose to leave this just as it is. Now again, if you multiply that through, have fun. It's algebraically, it can be done, but there's nothing wrong with leaving it. This is all over x minus 1. My hope is to get this to cancel. What am I left with up top? If you distribute this through, this is for everybody here. What do we get up top? 4 minus x minus 3? What is that? What? 1 minus? What's wrong? Are y'all okay? 1 minus what? 1 minus x, right? All this together becomes 4, take away x, take away 3. And then 4 minus 3 is 1, so you just get 1 minus x, yes? 1 minus x on top. All over this crap that we decided not to multiply out, because I really don't want to touch that unless I absolutely have to. And then all of that is over x minus 1, right? We're almost there.
Are you going to take out a negative?
I am going to take out a negative. Good. Y'all see that these are almost the same, right? These are almost the same. So if I factor a negative out of one of them, I can make it cancel. So you get to choose here. I'm going to choose the top. I'm going to pull a negative 1 out of the top. So I pull a negative 1 out of the top. And that turns that into an x minus 1. And then over the denominator that I did not want to multiply out. And then all of that over x minus 1. Now this part right here that I'm going to put in red, okay, I'm actually doing 2 steps in one there. I pull the negative out of these. If I pull a negative out, I'm left with negative x plus 1. That's what would happen if I pull a negative out of both of these. So I pulled my negative 1 out, but then I just flipped those over and made it x minus 1. And that's just so you can see the cancellation, that these two go away.
When you pull out?
Yeah? You sure?
Yeah.
Okay. Any questions? We're not there, right? I mean, eventually we have to take a limit, right? We haven't done a limit yet. This has all just been algebra, fun algebra, right? Limit, x is going to 1. Okay, what is still here? Got a negative 1 on top, right? That's this. And then all that crap that I never multiplied out is still there. There it is. Now, we should get a nice number now, because I no longer have that x minus 1 on the bottom. So when I take this limit, I'm no longer going to have division by 0. So let's let x go to 1, and let's see what we get. Direct substitution, I no longer have a limit. I get 2. Okay, what does this become? 4, square root of 4? 2, so I'm multiplying by 2. And then in parentheses, 2 plus, and then that again becomes 2. Okay, so be careful here. Don't mess it up. We've come this far. Don't mess this part up. Negative 1 over, okay, order of operations. Do this first. 4. So we have 2 times 2 times 4. 2 times 2 times 4, right? What's that? 16. Negative 1/16. That is the slope of your tangent line. So it's pitched down just a little bit, right? Now we got to get the equation, right? The equation. How are we doing on time? We'll take a break after this. Well, maybe not. Will we? I don't know. The equation, part B, the equation. For the equation, I'm using this formula, y minus v equals the slope of the tangent line at x, or times x minus a. So I'm using that generic formula again. For us, a was 1, right? A was 1, so we're plugging in 1 for a. All right, what was f of 1? We found that way earlier in the problem, didn't we?
1/2.
It was a half, right? Plug in 1, we get a half. And then equals the slope of the tangent line, which we found to be negative 1 over 16. And then x minus 1. That's it. This is the equation of the tangent line. Shall we verify or no? You want to see it? Doesn't take me very long. That was 1 over 1 over the square root. What was it? X plus 3, right? And then it was the point 1 half. Okay, in the red there, that is the graph. The red is the graph of the original function, and then we're looking at this point on the graph, and we're trying to find the slope of the tangent, the equation of the tangent line there, and we got y minus a half, negative 1 over 16, x minus 1. Got it. All right. So that algebra in that problem is kind of like, I'm not going to say the absolute worst algebra you're going to see, but that's pretty bad. I mean, in terms of you got to do a common denominator, then you got to do conjugate. So there's a lot of places to make mistakes. And we had to pull a negative 1 out, didn't we? So there's a lot of little algebra in there. Do y'all see now a little bit how I was saying, like, the ideas of calculus aren't the hard part? The hard part is the algebra of the calculus, right? The formulas are there. You're just going to do a limit. That's it. If you can do the algebra to get you the limit. All right, I'm going to put a problem up here. We're not going to do it. I'm going to put it up first, and then we're going to take our break. And while you're taking your break, you can think about the problem like, I do not want you to work this problem out, okay? I just want you to think about it. I want to know how it makes you feel. Okay, so let's let f of x be 1 over x cubed. 1 over x cubed. And for part A, I want you to find the slope of the tangent line at x equals 1. And then I want you to do it again at x equals 2. And then I want you to do it again at x equals 3. Then let's go at x equals negative 1. And then let's do it again at x equals, let's go with negative 2. And just for fun, we'll do it at x equals 5. Okay, let's take a break. What do y'all, we're going to do 5 minutes. Do not start doing this problem, okay? Just think about it. All right, we're going to take a little, 5 minute, 6 minute, 7 minutes? All right, well, what do y'all think about this problem? What about this problem do you not like? There's so many tangent lines we have to find the slope of, right? 6 of them, which means we have to do this limit 6 times and then do the algebra involved in each of those limits, right? Do we see how this could be problematic to do this? So because this could be problematic, what we can do is we can be a little bit clever about this. And that's instead of actually using a fixed number like 1, 2, 3, -1, -2, or 5, why don't we just use an arbitrary number? Like make up a number that's not a number, like a variable. Know what I'm saying? Like instead of doing it at x equals 1 and then x equals 2, why don't we do it at x equals a? And then see what happens. Let's just try it and see what happens, all right? So I'm going to put over here, no, let's do hell no because it's fun, right? It's summer. We're not doing this, all right? Instead, we're going to say, let's do it slope of the tangent line at x equals a. See, we're keeping a as a variable. What we should expect, and see if this makes sense to you, whenever we do, if we were to do these, do y'all agree we would get numbers as answers? And that would be the slope of our line? Here, we shouldn't get a number as an answer because we're doing it at a. What we should expect to see is some sort of like formula at the end that has a in it. And then what we can do with that formula is then just come in and plug in these values to that formula. In other words, we'll only have to do the limit one time. If it all works out, hopefully the way we hope it will, right? So let's write the definition. The slope of the tangent line will be the limit as x approaches a. See, I'm just using the generic formula, f of x minus f of a, all over x minus a. All right. So let's continue here. Who's up here? Juliana, you're up. Oops. Okay, so my question to you is, we're not replacing a with anything, right? We're leaving it. So what is f of x? What's our function in this problem? 1 over x cubed. Okay, so we got limit x approaches a. We get 1 over x cubed. Now, Juliana, what's f of a? What if I told you to plug a into that function? What would you get? Into this for x, right? Replace that x with a, replace that x with a. 1 over a cubed, right? So that's the function evaluated at x. This is the function evaluated at a, right? That's what it is. And then all of this is still divided by x minus a. Make sense, Juliana? Okay. Now, Edgar, where's Edgar? All right, Edgar. You okay with that step? All right. Edgar, any ideas? I mean, we already should know that if x goes to a here, we are going to get 0 over 0, right? So what sort of algebra are you thinking about here? Common denominator. Yeah, let's do a common denominator between these two. And I'm going to move a little bit faster here. What I'm going to do is I'm going to squeeze it right in here. I'm going to do a cubed over a cubed here, because I need an a cubed and an x cubed on both. Here I'm going to do x cubed over x cubed. Is that all right, Edgar? Yes? Yeah, let me do that over here. Okay, so you're putting them together already, right? Okay, so you said it will be limit, keeps coming, right? Limit, x approaches a. Okay, you said it would be a cubed minus x cubed, a cubed times x cubed. Yes? And then all over. Okay, Edgar, what are you hoping is going to cancel here? The x minus a. You're hoping that this is eventually going to go away, right? Any questions on what I did here, putting those together? All right, you're hoping that those are going to go away. All right. You could take out a what? A 1 cube. Do you recognize this? What is that? Difference of cubes. That's a special formula, right? A difference of cubes. So you refer to your formula sheets if you don't know it off the top of your head. According to your formula sheet, it would be a minus x, a squared plus ax plus x squared. All over that common denominator. All of that over x minus a. So again, what you see here in this blue, right, is this right here, right, difference of cubes. Do I need to write the formula down, or y'all okay? It's in your sheets, right, your formula sheets? I gave these out on the first day. Yeah. So we're okay with this then? Everyone, does everyone follow this from the formulas? Could everyone do that? Yeah, good. So you all see that this almost wants to go, right? Almost. We just need to pull a negative out of here or a negative out of here. It's your choice. I'm going to do the negative on the bottom. It really doesn't matter where. And then it's going to go away, and we're going to be happy. So we're going to get limit x approaches a. All right, leave the a minus x times a squared plus ax plus x squared all over the common denominator, which was a cubed x cubed, all over the negative that we pull out, -1, and then now the bottom becomes a minus x. And again, I skipped that step where I pulled the negative out of here, and then I flipped it, I changed the order. And what we were hoping, what we were hoping would happen is now happening. The a minus x's are gone. And so on my next line, I should be ready on my next line to take a limit. I'm just cleaning up here. A squared plus ax plus x squared over the common denominator, a cubed x cubed. And then, don't we still have a -1 down here on the very bottom? So what I think I'll do is, why don't I just bring that negative out here in front? Like just make it like negative of this fraction. You could put the negative on the bottom or up top and distribute it, or just put it out front. I'm just going to choose to put it out front. Just don't forget the negatives there. All right? Last step. Let x go to a, right? So everywhere you see an x, replace it with a. And let's see what we get. No more limit, right? No more limit. I'm letting x go to a. So I have negative a squared plus a times, I'm letting that x become a, so a times a, plus that x becomes a, so a squared. And then all of that over. On the bottom, a cubed times, I'm letting that x become a, so a cubed again. So every x got replaced with a. Isn't the top a squared plus a squared plus a squared? Yeah. And that's 3a squared, right? So minus 3a squared over, the bottom is what? How do you do that? A cubed is, times a cubed is a to the, what are you doing to those exponents? Adding them, a to the 6th. And you reduce this, yeah. This would be -3 over a to the 4th power. So just cancel 2 of the factors of a. And I put that negative kind of up top because I was running out of room. So this algebra kind of sucked, okay? However, we now have a formula, right? This formula will give you the slope of the tangent line at any value of x you want now. So if you give me a list of 10 different places you want me to find the tangent line, I just have to just plug it into that. I do not have to do the limit over and over and over and over. Isn't that efficient to do it that way? So going back to the original question, right, that I said hell no on, I can do it now. If I want the slope of the tangent line at, what was the first one I said, 1? At x equals 1, then what I would do is I would take this formula, -3 over a to the fourth, right? And I would replace a with 1 to the fourth. I get -3, right? All I'm doing is replacing that a with 1. Then if I wanted to know the slope of the tangent line at